ಆಯ್ತು ಪ್ರೊಫೆಸರ್ ಲೈನ್ ಸರ್ ಆಗಿದೆ ಸರ್. ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಥ್ಯಾಂಕ್ ಯು ಪ್ರೊಫೆಸರ್. ಸರ್ देखिए थोड़ा चिरंत को बुला दो मैडम पंडित है
ಹಲೋ
ಹೇಳಿ ಮೇಡಮ್.
ಸರ್ ಅವ್ರದ್ದು ಒಂದು ಆಮೇಲೆ ಫೋಟೋ ತಕೊಂಡ್ಬಿಡ್ಬೇಕಾ ಸರ್? ಅವ್ರು ಮಾತಾಡ್ತಾರ ತಂದ್ಬಿಟ್ಟು ಅವ್ರಿಗೆ ಅದನ್ನ ಹಾಕೊಟ್ಟು ಕಳಿಸ್ಬಿಡೋಣ ಅವ್ರದ್ದು. ಆಮೇಲೆ
ಏನ್ ಫೋಟೋ ಮೇಡಮ್?
ಅವ್ರದ್ದು ಮಾತಾಡ್ತಾ ಇರುವಾಗ ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ಒಂದು ಫೋಟೋ ತೆಗೆದ್ಬಿಟ್ಟು ಮೊನ್ನೆ ನಿಮ್ದು ಹಾಕಿದ್ರಲ್ಲ ಪ್ರಿನ್ಸಿಪಾಲ್ ಆತರ.
ಆಯ್ತು.
ಹೇಳಿದಾರ ಅದೇ ವೇಣುಗೋಪಾಲ್ ಅವರು ಬಂದಂಗಿದೆ.
Hello, can you hear me?
Yes, sir.
Yes, sir. Oh, okay. Okay, right, sir. I'm just checking whether. Okay. ನಾನು ನಾಗರಾಜ್ ಮಾತಾಡೋದಪ್ಪ.
ನಮಸ್ತೆ. ಅದು ಹುಡುಗರು ಅದೇನೋ ಅವರಿಗೆ ಶಿಫ್ಟ್ ಇದೆ ಅಂತೆ ನಾಳೆ. ಸಿ ಸೆಕ್ಷನ್ ಅವರು ಈಗ ಫೋನ್ ಮಾಡಿದ್ರು. ನಾನು ಇರ್ತಾರೆ ಅನ್ಕೊಂಡು ಅವ್ರು ಕಳಿಸ್ಬಿಟ್ಟೆ ಇದು ಲಿಂಕ್ನ. ಅವ್ರು ಫೋನ್ ಮಾಡಿದ್ರು, ಇಲ್ಲ ಸರ್ ಶಿಫ್ಟ್ಗಳಿದೆ ನಮಗೆ, ಬಫರ್ ಕ್ಲಾಸ್ ಅಂತ ತಗೊಂಡಿದ್ವಿ, ಅದಕ್ಕೆ ನಿಮ್ಮ ವಿಷಯ ನೀವು ತಿಳಿಸೋಣ ಅಂತ ಫೋನ್ ಮಾಡಿದ್ರು. ಡಿಲೀಟ್ ಮಾಡಿ ಹಾಕಿ. ಮೋಹನ್, ಅದು ಒಂದೇ ಒಂದು ಅದರ್ಸ್ ಅಂತ ಇದೆಯಲ್ಲ, ತೆಗೆದ್ಬಿಡಪ್ಪ. ಬೆಸ್ಟ್ ಸ್ಪೀಕರ್ಗಳಲ್ಲಿ ಅದರ್ಸ್ ಎರಡರಲ್ಲೂ ಇದೆ, ತೆಗೆದ್ಬಿಡಿ ಸಾಕಷ್ಟೇ. ಅಲ್ಲಿ ಇವರಿದ್ದಾರೆ ನೋಡ್ರೆ, ಶಿವರಾಮ್ ಇದ್ದಾರೆ ನೋಡ್ರೆ, HOD MCA. ಅವ್ರು ಇವ್ರಿಗೆ ಹೇಳಿದ್ವ ನೋಡ್ತಾರೆ ಇವ್ರಿಗೆ. ಹಲೋ, ಅಲ್ಲಿ MCA ಅಲ್ಲಿ HOD ಇದ್ದಾರೆ ನೋಡಪ್ಪ. ಇದಾ ಫೋನ್ ಎತ್ತಲ್ಲ ಮತ್ತೆ ಏನ್ ಮಾಡ್ತಾ ಇದ್ರ ಅವರು?
ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ವಾ? ಹಲೋ ಸ್ಮಿತಾ ಮೇಡಮ್, ಸ್ಟಾರ್ಟ್ ಮಾಡೋದ ಮೇಡಮ್? ಬಂದಿರಲ್ಲ ಬಂದಲ್ಲ ಆಗ್ಲೇನೊಂದು ಬಂದಿದೆ.
Sir Venugopal sir, can we start?
Yes, sir, I'm ready. I'm quite ready.
Okay.
You start.
Okay, sir. Thank you. Good afternoon, all. I welcome you all for the fifth day and final day session of Trends and Opportunities in Consultancy and Management. Today we have a speaker, Mr. Venugopal, Managing Director, Venugopal Automation. Sir will be speaking about consultancy and opportunities in industrial and process automation. And after that we will have a validatory session at 5 o'clock. It lasts about 30 minutes, not more than that. I request all the participants to remain connected after the session, so wherein we'll just spend some time to reviewing what all is being done and your opinion about the program. And you will also receive two feedbacks today. One is the current speaker feedback and another one overall feedback. So you need to enter both the feedbacks to get a certificate. Okay, more about that we'll talk later. Now I request Professor Smita Madam of Electrical Engineering Department to welcome today's speaker. It is over to Smita Madam. Madam, you can start. Hello.
Thank you, sir. Thank you, Dr. Nagaraj. Indeed, it's a pleasure to welcome Mr. Venugopal R for the presentation today. Mr. Venugopal R, an electrical engineer, started his career as in the R&D engineering of Kirloskar Electric for 4 years. He worked as in the field of power electronics and embedded systems. He later joined GE Automation USA and was transferred to Singapore as a vertical markets manager. He was promoted as a regional manager to head a team of professionals for executing projects all over Asia Pacific region. While in Singapore, he executed automation projects in various applications like steel plants of Australia and Thailand, dairy and processing plants at New Zealand, automatic plants in Malaysia, semiconductor systems in Taiwan and Philippines, oil and gas plants at Vietnam, cement plant, Thailand, and many more. And he earned extensive knowledge about the process of know-how and application knowledge. During this tenure, he traveled throughout in and out of Asia Pacific region and executed automation projects in more than 20 countries in the region. With his rich international experience, he came back to India from Singapore in 2004 and started his own company titled Venugopal Automation. As a managing director of Venugopal Automation, he leads a group of professional engineers and is executing many projects. One of them are the Defense Urban Battle Tank, ACC plant in Saudi, hybrid generation project in Singapore, and many more verticals. Today, Venugopal Automation has branch offices in major cities of India. He is also executing projects at Palau, Ubin Island in Singapore, Dubai and Daman, Saudi Arabia, and many more. He has been giving presentations at many colleges and conducting a lot of workshops, motivating most of the budding engineers to come into automation field. I thank you very much, sir, for having accepted our invitation. Now you may start off with the presentation, sir.
Okay, thank you, madam. Can you hear me now?
Yes, sir. We can hear you.
Okay. What we will do, I gave a lot of talk on automation, lot of talk on entrepreneurship, different type of people call us. Last time I was in a Rotary Club, so we gave a talk on automation from an employment point of view and all that. So career counseling, so many types of talking. This is the first time I am talking on consultancy. Very recently, I spoke a little bit about consultancy. This topic came up in one. By the way, I'll also give a little bit more introduction. See what happened. I'm on the board of directors of many colleges. This is out of my interest because this has nothing to do with what we produce. Okay, what we manufacture is very big, which no colleges will use. So one of the topic came was this MBA and all this accreditation. They're asking the faculty to do some consultancy and all. This topic came up with our own professors when I was talking to them. See, what is my view on this consultancy? There are three aspects for this consultancy. We as a supplier of automation, we are automatically consultants. I will show you some of the videos. After this, I will share. So how I want to divide this topic is, see, we have now it is almost 3:40. Okay. Now up to 1 hour, I will take on what all the type of consultancies we do. Okay, as a process automation, and what is the knowledge required in all these different types of automation. Especially in automation, there are different branches of automation. Okay, we call general automation. Then we call process automation, industry automation, process automation. That itself is that there is a huge difference, because what we call as industry automation, the type of concepts are very different. Now process automation concepts are very different. Then comes robots. Robots are again industry automation. It is a branch of industrial automation, but they are specific to particular application. Then comes data acquisition. Like that, there are many branches of automation. Now, what is important in automation? The first and foremost point in automation is ours is a totally multidisciplinary. So we should have a knowledge of mechanical engineering. We should have a knowledge of electrical engineering. We should have knowledge of instrumentation. We should have knowledge of electronics. All are combined, including computer science. So I am going to show you some screens. So this is a topic which we are going to come at the end. This is called SCADA system. What I want to do, next 1 hour, I would like to speak on the automation, and last 10 minutes I would like to spend on this particular topic. I am going to share this screen, so you can take a look. This continuously I will share this screen. If you can see the screen, you can just tell me. Are you able to see this?
Yes, sir.
Yes, sir.
The screen
Screen is visible.
Screen is visible?
Yeah.
See, can you see this?
Yeah.
This is a steel plant. This is called data acquisition, SCADA. I'm going to talk about the software at the end, not now. But let it keep running. I'll try to acquire some data out of this. This is called supervisory control and data acquisition. This is one of the most modern type of work we do in automation, where there are no expertise. Because SCADA is okay. General SCADA is there are a lot of people, but there are specialization in SCADA itself, like power SCADA, which is used for power systems by electrical engineers. There is what is called fish tracking system in automotive. So such SCADAs are very special. And you know, just experience of SCADA, in power SCADA with a 2 to 3 years experience, the salary can be as high as 3 to 4 lakh rupees. Because we do a lot of work in Middle East. I'm going to show you some of those videos. So a lot of people call us from our clients in Middle East. They say, sir, do you have anybody in power SCADA? Do you have expert in this? So we are ready to give 3 lakh rupees salary. So there is a lot of huge opportunity in this area of automation. Okay, so industrial process, all types of automation. There are a lot of opportunities. But only thing is that you have to dedicate yourself, because there is nothing called mechanical engineering, there is nothing called electrical engineering, nothing called instrumentation, electronics, there is no such words, because you are expected to know the entire process. So as a consultant, see, consultant's main role is, why consultants has to be multidisciplinary, because in one plant you will have mechanical division, you will have electrical, electronics, everything. So but consultant is ultimately responsible and he has to give suggestions or anything that is related to any of the process. He should know. So that means process knowledge is required, system knowledge is required. Third is the project management. These are the three essential components of consultancy. Now let us understand what is process knowledge. We'll try to go one by one. See, I will show you the video of some of the projects we do. See, we are one of the pioneers in this automation. Okay, this is called AAC block. See, this is our Saudi Arabia project. Last year, we did a very big project in the Middle East. Okay, so I'm not going to bore you with any PPTs. I don't like to do that. Mine is a live demonstration. It's all real-time applications. So we don't deal with any theories. It's all practicals. So what do we produce? See, this is a plant where we produce, we call AAC, aerated autoclave. So these are all actually bricks used for building. Only in our country, we use cement blocks. In our country, for all building our buildings, we use cement blocks. Whereas throughout the world, people use only this type of blocks. This is called AAC. What is AAC means? Aerated autoclave. Here we use fly ash. After burning the coal in the power plant, a huge amount of ash will be left. That is called fly ash. We utilize this fly ash and make a brick for construction of buildings. Okay, so this is one of the very last 4 or 5 years. This is the one area we have done a lot of work. I'll just take about 5-10 minutes just to go through, and what is consultancy in this is very, very clear. That's the reason I'm trying to say. So what we do, this is again SCADA. I showed you one SCADA system. This is SCADA for that particular plant, for Saudi Arabian plant. I will try to reduce the volume because whatever is noise in the thing is coming. So here, and mix them into a slurry. So this is a tank in which slurry is stored. Now these are all powder, cement, silo, gypsum. There is what is called a screw conveyor. I think if there are mechanical faculties on this, probably they will connect. What is a screw conveyor? Screw is a conveyor which will look like a screw. But this is best for conveying the powder. So when you turn the screw, so the powder will slowly fall. So that you have a very fine control of the screw, a very fine control of the powder. This is called screw conveyor. So these are all pumps for liquid use pump. So here this is a weigh hopper. What you see here is showing the weight of the what is the liquid. So we measure the liquid, we measure the powder, then we measure the aluminium, mix all of them in a mixer. So this is how this plant produces that slurry. This is the panel. These are all our equipment supplied by us. Okay, so all this is manufactured in our factory. So we manufacture these types of panels. So these are customer who is a machine builder. So we produce all this in our factory and we export it to Saudi and different parts of the world. So what exactly we do? See, this is the tank. See, it's such a huge tank. Okay, with all this slurry pumped and all these are pumping. This is a place called Jubail, which is Saudi Arabia. It's one of the very big industrial city in Saudi Arabia. It's almost 100 kilometers long. Can you believe 100 kilometers? You will see only industry. So we make a slurry out of this. Then we add them. This is say like this. Now I will explain the process a little bit because this is a very long process. But what is required? First is this process knowledge. Be successful in becoming consultant. Because why I am saying we are only automation supplier. But however, we are involved right from the beginning. Once let me finish this, then I'll come back to the consultancy portion. See, we have a screw conveyor here. That what you saw on the SCADA, this is the actual screw. So powder comes from this circuit, liquid comes from this circuit. They all get mixed in a mixer. This is a mold. Okay, because we have to test liquid into a mold. So what do you see here? Now there is a controller in this. These are all intelligent controllers. There is a controller inside this box, and there is one more controller on the top. They are talking to each other on wireless. So there is no wire connectivity because this is a moving car. Once you see here, once we pour all the liquid, it starts moving. And we can't put wire to this mainly because it's very dirty. This is a very strong bonding cement. So this will damage all your wires. How does it get power? There is a power inside this. Inside this area, there is what is called a bus bar, a shrouded bus bar. So this gets power from inside, but all controls from wireless. So this mold, whatever we have poured, has to be left for 2 hours. We should simply leave it for 2 hours, just for without disturbing it, because that is where that chemical reaction should take place inside. There is what is called a bubbling activity that should take inside. So now what is happening? This car, this mold. See, ours, by the way, ours is a fully mechanized system. Okay, so whatever automation we do is totally mechanized. So you will not see any, whatever people you saw on the car, they are basically, these two people are fitters. What we are doing, when this car moves, there should not be any vibration. If it vibrates now, then this chemical reaction will collapse. So these fellows are grinders fellows. Actually, they just grinded this rail, and now they are taking a ride to see how much is the vibration. So based on that, they grind it again. So otherwise, all this moves automatically by itself. Okay, so now what will happen? This mold will be transferred onto one more car which is waiting this side. So okay, see, there is one more car waiting here. So this mold comes here and gets transferred onto this car. So what will happen to that mold? That mold, this is a car, again is a very intelligent car. So intelligence is built in everywhere. This is called distributed control. The control is not at one centralized place. This has got its own intelligence, this car has got its own intelligence, everybody is free to work, but they talk to each other on a wireless system. That's the beauty of this entire plant. You don't see much cables at all anywhere because they're all on wireless. So whatever mold this fellow received, he has pushed all here. See, you can see all these molds were pushed one after the first. They pushed here, 1, 2, 3, like that. It has pushed on its own. Now, after a certain time, based on the temperature, based on several factors, this fellow will decide now this mold is ready. It is hard now. Okay, the whatever liquid was there, it is now set. So now he is pulling this and he is going to put it into this another track. Okay, now what is the first effort of automation here is, imagine if somebody comes into this line and this car moves at great speed, you will get crushed. So safety becomes the topmost priority. One of the main reasons why you should have a thorough process knowledge is because in automation, safety becomes the topmost priority. Okay, so now after this mold is pushed, see this will come and push this mold onto this track. I am going to just accelerate a little bit because we hardly have 30-40 minutes to talk. So that's why I will try to push certain things a little faster. If there is anything, one more is coming now. By the time you push this, one more will be coming. This is a steam cooling chamber. Whatever you see here, steam cooling chamber. So whole thing will be sequenced that way. No time is wasted. By the time you push one mold, second mold is ready. So that is how automation improves productivity. Okay, now what is the biggest challenge for us? This whole bloody thing is 8 tons. The weight of this whole damn thing is 8 tons. 8 tons material has to come and park here with an accuracy of 100 micron. Imagine, see, if it comes and crashes onto the wall, what is here is just a wall. So if your control becomes out of control, then there is a serious accident. Look at this, it comes so close, it doesn't hit. Now first look at this area, parking accuracy, 100 micron. So the parking, see, look at the parking, so accurate it has to be, because otherwise from this rail to this rail, mold will not get transferred. If it doesn't get transferred, then if it falls down, finish. Next 3 days, your production is dead. Because you have to cut the rails, cut the so many things you have to do. Accident means very severe. And imagine one more thing. Suppose you write a wrong program in your controller, and when this fellow is half, if this fellow takes off, after pushing the mold, this fellow has to return back to push the next mold, did it not? Suppose at this stage, if this fellow takes off, what will happen? Mold is half out, half inside. Then you have a serious problem. So these are all what we call as interlocks. Very, very essential when we write the program. Okay, and what you see here on the back side is hydraulics. See, one of the great advantage of, I am an electrical engineer basically, okay, but I gave a talk in NIT Calicut on hydraulics for 3 days. Though I am not a mechanical engineer, but we know about hydraulics application, how to size a pump, how to size the cylinders, all these pusher is hydraulic power pack. Okay, this is hydraulic power pack which is actually pushing this mold inside. So once this is completely out, this will take off. That means we guide by another sensor. See, now this knows comfortably that is out. That means there is one more sensor here. That sensor, so somewhere here there will be one more sensor. If that sensor is on, that means mold is comfortably outside. So all these interlocks are very, very essential. So you need to have a knowledge of hydraulics, pneumatics, several fields. So if you want to be a consultant in anyway, there is a lot big process. After that we cut this cake. So this is a cake which gets demolded. From that mold, we remove that one side. This mold is 3 side openable. 3 side is one and 1 side is open. So this mold gets removed. Then this will get cut into pieces. See, this we are cutting by wire. Okay, then we tilt it. Lot of process will happen on this. Let us not go down to complete because this video itself will take now at least 1 hour to understand every process. So many types of cranes are there. So many types of cars are there. All are continuously working one after the other without any accident. last 2 years, producing 1,600 cubic meter. Okay, it's a huge plant actually. Okay, see top base cutting. Now this is waiting because this crane has to come this side. Unless this crane comes this side, this cannot go further. Okay, so now as soon as this comes back, this will go for further parts. Like this, different types of interlock. Then what will happen after you cut this cake? Okay, it gets bonded. This is another very tricky process. Now these are all things after cutting by a wire, because this is a very heavy wet cake. Now it is really wet. If you just press it, it will break. At this stage, it is very heavy. It will bond itself. That means it will get attached to one to one. Now if it gets attached to one to one, then removal becomes difficult. So we do another process called green separation, where what we do, we separate the green stage. The green stage itself, we separate each block separately. I'll show you here. Okay, you can come here. See here. This is all using servo drives, hydraulics, pneumatics. See, now this is separated. We separate each block. Now it is very wet actually. If you touch it, it will break. But we have to handle so smoothly. By using servo drives, ball screws, all these mechanisms we use because we want to reduce the impulse torque. So how a ball screw will reduce impulse torque? This is a subject of mechanical engineering. But automation fellows should know, because if you go for some vibrating system like hydraulics and all, will generate more vibration. It may not be as smooth as ball screw. So which system to go where is a very important knowledge that a consultant should have. Okay, so now see, now this is already bonded. Now I am separating this. Automatically we are separating this. So this is very tricky machine actually. Initially we broke so many blocks. Okay, after 2-3 days of trial, we could finally succeed. We could succeed in separating the block at green stage. Because after steam curing, it becomes very hard. You can't touch. It will be so hard. You can't even see. This is steam cured block. This is a green block. This is green. This is already dry. So like this, there will be so many processes in this tilting, with hydraulic tilting table and all that. Let me not go through every detail of this. Just for sake of see now to park this. Why I am telling why we have to work like consultant. This parking, how we got this order. See, we quoted against a multinational company, like Siemens, very big company. Against them, our company is named Venja Automation is honored. Nobody is honored. It is a very small company. Now, what happened? Before this order was being discussed, I went and we approached the customer. Customer was not willing. He says, no, I deal only with very big companies. We don't go to small companies like this Venja Automation, we are very small company. So, it was almost a cakewalk order for Siemens. He had already decided to give this order to Siemens. Then came, because already previously about 5 crores worth of orders was given to Siemens, and when the first plant was getting installed, they failed in this application. Siemens literally failed. Some young engineer went, he has no experience. So they failed in this application because this proper alignment they were unable to do. Sometimes it stops here, sometimes it stops here, sometimes. Why they failed? Because they used a encoder to this wheel. So whenever this wheel rotates, that encoder will make a number of pulses. Okay, I use a lot of these systems for training and teaching students. Okay, so see, I have this encoder with me. If you can see here, see, we call this encoder whatever I am having in my hand. We use plenty of encoders in our. That means once you want to know encoder, again instrumentation comes into picture. So you should have a knowledge of instrumentation, electrical engineering, electronics, because that acceleration, deceleration, that slow control. Again, you need a knowledge of drives and motors. So you need a multidisciplinary knowledge to be a consultant. Anyway, let me finish that story. So this encoder they had used. Now what is the drawback? The encoder is an excellent device, there is no doubt. But there is a drawback. What will happen if you put an encoder to the wheel? Now this is a mechanical device. When the wheel rotates, the car will not move exactly pi to d of the wheel. Okay, if the wheel diameter is 300 mm, we expect one rotation pi to d. That means 900 mm this car should have moved. But sometimes it will move by 890, sometimes it will move by 910, sometimes it will move by 850. That is because there is a slip, because there is a metal slipping. So due to that your encoder becomes erroneous. So if you try to use such product, then you fail. You fail miserably in this product. So then this customer said, what will you do? Will you go for this? Will you go for that? And I said, if you are going for encoder, then you miserably fail. And then what is the next solution? Then I gave him a solution. We have to go for external encoder. See, this is a sensor, we use laser. Okay, this laser sensor is fitted to the car. Now this will put a beam on the wall. Now when this moves, laser beam will elongate. Now this has no slip because I'm not having no metal to metal slip, because this is directly giving me direct distance between this wall and this car. I'm getting direct distance in the 32-bit format. What is 32-bit format? Again, electronics engineering comes into picture. You must understand a binary language for electronics engineering. 32-bit is a huge number. That means this entire length is 55 meters. I get some 55 crore number which is worth 55 crore. That means every meter becomes 1 crore. That means my accuracy will be better than 1 micron. 1 micron is only 1000 of an mm. So once I get a sensor which gives me exact distance, then I write a program. You slow down, you stop, all this. Now this is exactly the knowledge of consulting. So this is how I got the order. Moment I described them, if you use encoder, you are going to fail. You will miserably fail. Then he said, yes, I'm very glad that before using encoder, you told me that such a thing is not going to work, because we already fools, we gave 4 orders to them and all the 4 orders are under trouble now. So can you please help us? Then we got this order. It is a long story more than this. Let us now let us stop at this stage. Now, when this project was conceived, we were involved right from there, because what will happen? Layout formation. See, another very important aspect of consultancy is, now when these projects were made, okay, so by the time most of the automation people are called, the layout is already made, the machineries are discussed, everything is pre-made. So we come at the end. It's like our role is like like these police fellows come in the film. Police comes in, film is end. That's the last part. It will be generally like that. But then we insisted that if you involve us, this is the layout of the plant. See, this is that car. This is one more car here, one more crane here. So lot of now we are now involved right from here as a consultant. So they don't pay us any money. But what will happen? I give them a suggestion. Sir, instead of keeping the mold here, why don't you? Because initially this mold was here. Okay, something else was here. We moved the whole layout. We made this a drying area. Because what will happen? For the automation to be successful, we should have a shorter path. You cannot have your mold move all around the globe and then come here. By the time it comes here, we would have lost so much of time. Because we have to produce 1200 cubic meter. 1200 cubic meter means every 4 minutes we have to catch one mold. If I have to take one mold every 4 minutes, the path has to be shorter. If you try to make that mold move all the way, then you lose time. Then your automation will not be successful. And whatever amount of crores or rupees you invest becomes waste. So consultant's job is very, very crucial, because now we do automation after the machinery is selected, but consultant work starts right from the beginning. Because even on the drawing sheet, because even before the layout is made, this is maybe 10th layout we made. Then we frozen, because this has all the advantages, this is a shorter path. Then somebody will come, Vastu fellow, sir, boiler will put here because Vastu. All that nonsense you have to incorporate. Because I don't care, because see, because of that Vastu, there is so many things got changed in this plant. So all that nonsense will be there, because we cannot avoid. But this is how the consultancy job is very important, because you must have a thorough knowledge of process. Process knowledge is absolutely necessary. Without that, you can never become a consultant. Number one. Number two, system knowledge. Like I showed you, so many. What is the role of encoder? What is the role of laser sensor? What is limitation? Why I cannot use that here? Why I should not use that here? So that knowledge of system is secondary, second matter. Okay, we will come to that. We will just move a little forward from this. I hope it is interesting, because these are some of the things probably not taught in any textbook. Okay, so whatever I am going to teach you is not taught in any textbook. So this is one type of project we do. Now, instead of this is block making, we also do one more type of project. Here again I am a consultant here. Consultant, supplier, everything. Consultant free of charge, supplier, because they expect us to do every consultancy free, because they are giving us order. But for me also it's good, because I am insured of order, because nobody knows the client better than me. So instead of believing somebody who doesn't know, customer will be more happy to give me order, because I am involved right from the beginning. What is this? This is a different type of plant. Here we built 1,100 houses in 8 months. Can you believe? In 8 months we have built 1,100, like the 7 towers. How do we do? If you take block by block, and you try to construct this wall, it will take ages. So like your college buildings, they are all used by those blocks and your constructed. It would have taken 5-6 years or 4-5 years to construct a building like this. What do? We make the wall itself in the factory. Every 15 minutes we cast one wall. Okay. So how does it work? This is again another different. I will not spend much time, but I'll just give a brief idea. What do? What you see here is the blue color, the plotter. So after you make the drawing of the building, we allot a number to each of this wall. For example, you take this wall. This wall number 1. This wall number 2. What is the difference between this wall and this wall? Here there is one window. Here there is one big door. There is a balcony door. So here this side wall has nothing. It's a straight plain wall with no window, no nothing. Okay, like that, different walls are given number. What we do? There are 11 floors in this building, and there are 7 towers. So this 77 walls will be manufactured, not at the time, but 77 walls will be made. So what is based on the height of the wall, this starter will this is a moving circulation effect. This whatever metal that you are seeing moves from here to here. It's on roller. You can see here, they're all on roller. So it moves from there to here. Now this will plot what is the size of the wall. Suppose I want 10 feet wall, it will only plot 10 feet. Suppose I want 15 feet wall, it will plot 15 feet. And what is this opening? There are windows, doors, all that openings has been filled up. Then what we do? We do what is called cage making. So if these steel bars are inserted, then all these electrical pipelines, plumbing pipelines, they're all drawn before itself. See, one great thing is all are done in the factory itself. This plumbing line, everything done in the factory. This is a factory, so nothing is done on the side. So after all these lines are put, this crane will come, one more crane which is on the other side will come and pour the concrete. After pouring the concrete, we vibrate, then call it. Look at the finish of this wall, fully finished. That means no plastering required. Just right, you can paint this wall. It is brought to that shape. Imagine all this happen in 15 minutes. Every 15 minutes we produce one wall. Then this crane, where is it? Okay, this crane, this is called very big crane. See, this is a big challenge. Lifting so many tons of material up, then pushing it into curing chamber. So that wall will be cured for about 8 hours in steam. So every 15 minutes you put one in and you take out one. You put one and take out one. That's all you get every 15 minutes on wall. Then these walls are transported to the site, wherever that site we are getting erected by a lorry. We're using these lorries. It is mounted on the lorry by a gantry crane. This is a gantry crane which lifts this and puts it. So then it is erected by a tower crane. You would have seen tower crane on top of many buildings. So this is a tower crane which will simply lift that wall, place it here. Then they put a sealant, gum. That's how. Very simple. So for about 8 months, you have a building, your building completely ready. Look at this. This is a tower crane lifting a wall and just place. So these are very new construction methods. We also do a lot of work in this field. Anyway, I will not spend much time on this thing. Then we just to show you, because I am trying to show you only construction type of automation. We also do automation. This is another very big field. Okay, just now Madam was mentioning, Pulau Ubin is an island. So we have done a lot of work in this island in Singapore. Basically, this is a hybrid generator. This is not any moving thing. Here we use diesel engine, wind and solar. Of course, wind is not there now because this island, a lot of birds migrate into this island. They don't want any bird to die because of this wind blades. So only these two are there. What exactly is this project? Another type of automation, which needs a very thorough knowledge of electrical engineering. This is called doubly-fed injection generator. What exactly we do? Now this diesel engine runs at different speed to save diesel. What will happen? This island is a tourist island. A lot of people come to this island. So this is our actually generating station. Okay, we on the top we have put the solar panels. Now in the morning, sunshine is very bright, very bright. At that time, lot of energy is generated, but no taker, because nobody has come to the island yet. Because we have to take a ship, we have to come by a ship and all that, ferry and all that. It will take time to come to the island. So at 9 o'clock, there is a bright sunshine. Nobody is there. Then what our system will do? Our system will pump the water, then start the ice making. All that energy utilization we do from this panel. Then we generate 3.2 megawatt. Can you believe 3.2 megawatt we generate? In the afternoon, when all the people come to restaurants, at that time air conditioner, so many heavy load comes on the system. At that time, we switch on the diesel engine, we run at different speed. So diesel engine itself is a very specially made diesel engine to run at different speed, so that whatever is the shortfall from the renewable energy, that will be compensated by this diesel engine. So thereby, previously, before installing this system, all the hotel had only generator. They had their own captive generator. Now they were all removed, and now we are giving power from our system, okay, which has got all these PLC controls and all the things. So it's a very, very big project actually. So the other type, so many types of projects we do. We do foundry automation. I don't think I will have time to go through each one of them. We are already 4:10. Okay, so I do not want to see here also a lot of knowledge is required to do a foundry automation. Now to do a foundry automation, I'll just give you a simple example. What happens? See, while we were commissioning this foundry, how it works? Basically, you pour a hot metal from a furnace, from arc furnace. This is arc furnace. You melt all this metal, all the scrap metal, some other metal. So they all added together in this arc furnace. Now from this ladle, the hot metal is tapped. Now and it will be poured onto the mold. You can see here on this mold, sand mold, small hole is there. So you pour this hot metal, then you get a shape, whatever shape you want to get. Now what exactly this customer does? This plant is in Trichy. So what exactly this customer does? They produce balls, round balls for cement plant. In cement plant, when you want to powder, even in the power plant, when you get coal, this coal will be lumps. Somebody has to sit down and powder it. Then only it will burn very well. For powdering, 15 tons to 20 tons an hour coal is required in a power plant. Who will sit and start powdering this? So this will be done by the ball mill. So that ball mill needs a steel ball, which will, when you rotate that ball mill, it will hammer and make a powder. So this company produces the steel balls. So this you look at how we have placed our panel, and what is the type of environment we work. Anyway, that's a different story. Now I want to show you some very interesting part of this. Now sand plant is one area in foundry where so many belt conveyors will be there. Conveyor will carry the sand from 1 to 2 to like that. Then there will be a bucket elevator which will lift it vertically, then fall into silo. Like that, like so many process. One more bucket elevator, one more belt conveyor. So what will happen? These belt conveyors are underground, unattended. Some things happen very easy. One day it caught fire. Okay, one day it caught fire. The belt conveyor caught fire. So how belt conveyor will catch fire? What is the modality of that? So this is something actually just very recently we concluded one for 190 students. We made a internship for 1 month internship. I showed them all these things and I explained to them what is this batching plant and all those stuff. See, anyway, let us come back to this. See, this is a belt conveyor. This is a batching plant with load cell, pneumatics. This is a pneumatic cylinder. We teach so many things. Knowledge of pneumatics, everything is required to be successful in automation. Okay, now let us get back. This is a belt conveyor. So this belt conveyor is hung by a load cell. In this plant, what we are doing, see, this is a load cell. If you see here, you can see a S-type load cell here. So this gate will open, allow the material to fall until we achieve the weight. Once the weight is achieved, it will close automatically. So it will close automatically. How are you measuring the weight? You are measuring the weight by a load cell. Okay. So see now, this is the load cell, S-type load cell. This load cell is this belt conveyor, which is, can you see a small belt here? Not small, but in a small place. This belt is hung by a load cell. The belt is actually hanging. If the material falls onto the belt, this will get a force. Based on that force, you are going to, based on that force, you will be measuring the weight. Now, what happens? On this sand plant, this belt many times is stuck. See, if the material becomes overload, suppose instead of small lump of sand will fall, then material will get choked. At that time, these rollers will be rotating, but belt will be stuck, belt will not be moving. At that time, due to friction, it will catch fire. So what do? For these idle rollers, we put one sensor called zero speed switch. So whenever belt is rotating, that roller will be attached to this belt. It will be pressed against the belt. Belt is moving, that roller will also rotate. If the roller rotates, then the pulse will come first. One sensor will become on and off continuously. So as long as we get that pulse on and off, okay, that means this belt is physically moving. Then we keep quiet. Moment we don't get that pulse, that means belt is stuck. Immediately we stop this belt, not only this belt, we stop all the preceding belt. That means all these previous belts. Suppose this is BC5, belt conveyor 5. Then we have to stop 4, 3, 2, 1. All of them have to be stopped because already this is choked. You should not push further material. So these are all different process knowledge required if you are working in foundry, if you are working in power plants. So lot of varieties of knowledge required. So you cannot become a consultant in every field. I'll tell you what exactly the consultancies you can do as a college. Okay. So by the way, anyway, now we try to impart a lot of this knowledge to students. These are all students who come to our factory. Okay, many times, lot of students. Okay, this is what we manufacture in our factory. These are all air circuit breaker panels. Okay, this is for Kesoram cement. So whenever they come, whatever is going on in the factory, we try to show them. We try to make them learn, because what will happen? This knowledge is required for them, because they should know, come with system knowledge. Okay, so knowledge of each of these components we use, like MPCB, motor protection circuit breakers. Okay, so we use, this is a PLC, these again MPCB, contact, a lot of these devices which we use. So we use for protection. See here, if you see here, This is the incoming circuit breaker for the entire panel, the electrical protection. So we use what is called a CPCT. Okay, we do a pressure oxy here. We use one type of control, which basically, if somebody gets a shock, immediately this will open the breaker, cut off the power. So a lot of these protections are done. This is called earthly engineering. So we have to have a knowledge of electrical engineering. We have to have a knowledge of mechanical engineering. So many. Then in electronics, instrumentation, computer science. I will come to computer science also. Last 15 minutes. Now it is 4:15. I will close by 4:45, so that you know if there is any questions, any interactions, you can ask me. We can keep it. Otherwise, our talk generally goes for 3 hours. Okay, with so many things to be shown. But anyway, we'll restrict. I don't want to bore you people. Okay, so this is another. Okay, so now knowledge of all these things will be required. Okay. Okay, I want to show you one last thing before we move on. This is something because you people are faculties. That's the reason I'm trying to show you this. See, this is we did some work for Arjun battle tank. Okay, so this is the main gun. There will be one more gun called auxiliary gun. See, one of the project we did was for missiles. You know, these are all the different missiles that are kept in the bin. So we have to find out which missile is there in which bin. Because after in the warfare, what will happen? They will remove the missile, they keep firing. So what is left in the bin will not be known to them. So we have to use a very special sensor to find out what is it. How do you identify missile 1 to missile 2? Is only the tip. Only from the tip only you can identify. Because backside all missile looks same. Height are some different. Some are different in height. Some are different in base. Radiuses are different. So we use a very special ultrasonic sensor because these sensors cannot, if you try to use a laser sensor or any other type of sensor, so that may develop a local heat. So I use this type of sensor. I just try to grab this here. So this is the sensor which we use there. This uses sound waves. We use a sound wave. This will produce sound waves, get a reflection. Based on that, we measure what is the diameter. The diameter, the slope we measure. For making points, when this is pushed, we measure here, we measure here. Now, between the two coordinates, we do delta x and delta y. Okay, we know what is y and what is x. Based on that, we calculate the radius. So, whatever I learned analytical geometry, long back, all that we can use. Okay, so that is one part, but very big part, which I will try to show you now. So, why consultancy job is not easy. Okay, you need a lot of things. But, whatever projects I am trying to show, it is almost impossible for somebody to become a consultant unless you have minimum 20-25 years of working experience in this field. Otherwise, this will be a very difficult field to work. But anyway, I will try to let me continue a little more on this. 1 minute. Where were we? Okay, we were here. Okay, no, we were here. Okay, here. Okay, so there is one more project we did was for gun. See, this is a gun which is used for shooting aircrafts. Okay, now this is this gun. This is our video inside our factory. So this gun previously, what used to happen? The man has to. This is how the gun will be mounted. Man has to come out and shoot. This is how it used to be long back. Okay, so before all this advent of AD gun and all that. So when a man comes out, opens the cap of a gun or tank and comes out, then gone. He's gone. He is now susceptible to all type of attack from the air. They will simply drop a missile inside and everything gets destroyed in no time. So what is that we have to do? We have to use a special motors. These are all BLDC motors. Why we have to use brushless? Is a different EMI, EMC complex, so many things. What is very important? Look at this gun. It stops instantaneously at such a great speed, 45 degrees per second. Presently, it can run from 0 to 45 degrees per second, and it stops. That means no hunting on the gun. No hunting on this motor. Now, to do this itself, you have to write a very special algorithm. Okay, now anyway, I will go back to, there are a lot of things on this. This is a 45 minutes video. So I don't want to emphasize it. So I don't want to, so what is very important? These platforms are very immediate. When this gun, and the tank is because in the warfare, you don't know where tanks are driven. So when it enters the tank pit, what will happen to your gun? You are going to shoot an aircraft, and and instead of shooting Pakistan aircraft, you will end shooting Indian aircraft. Okay, so that's the measure the disturbance, then that immediately. Now this is one very big story. We took almost 6-7 months to develop this because what will happen? This will how much disturbance. Okay, how many angle, what is the magnitude, all the information will get. But quickly, you should not be anything constant of this. Okay, now initial stage, when we did this project, when we just check it used to take so much time to come back. Okay, so because otherwise, if you don't correct them quickly, there is a lot of escape for this. So that is where the knowledge of control system became very useful. See, when I was a student in electrical engineering, control system was one of the what we call cabinet kernel, very difficult subject to learn and understand. And I never understood anything. Whatever board plot, root locus, whatever we wrote, everything was imaginary. And what is the stability of the control system? We wrote something, some book is there, read, some questions will come in that, and write exam and pass. Now, after so many years, this was done in 2000, I think 10. This project was 2010. So after 20 years, I had to relook at control system because I had to understand how to do a mathematical modeling, then how to use these plots to stabilize the system within say 15. If you don't stabilize the system in 15 milliseconds, your gun will never control, because we had used motors with 180 millisecond response time. Now 180 millisecond response time will be fraction shorter. So by putting all these calculations and all these mathematical modeling and all these Fourier series transformation, all things, whatever you learned in the final year of my engineering, all that became useful to me. Because see, the biggest drawback of our curriculum is whatever we study, we don't know where to apply. Maybe at that time I was very afraid to ask this question to any of my professors. I asked, sir, where do you use all this nonsense? You are teaching so many nonsense from this book. Is there anything like this available in the world? Can I see something like this? So all those questions was remained with us. But when I made this project, this was a fantastic project where we learned so many things about engineering. So that really made me an engineer. Anyway, I don't want to waste a lot of time explaining these things. Okay, so because we have many things to talk. Now, if you want to be a consultant in these type of projects, there are consultants. There are a lot of people, but they are mostly minimum 25 to 30 years of experience, working experience in this field. Okay, so we do different type of projects. We do anyway. I just want to don't want to get into further videos. Okay, maybe this one may be required. This is again for the Dubai project. We do a lot of work in Middle East. Barrels, we produce this type of barrels. I use this in my talks very regularly, because when I talk to students, so especially the 7th semester students, we want to teach them what is an encoder, how to use an encoder. So I just show you by using encoder, we failed in one project, then we went for somebody used encoder and we went for there. But the same another plant, I'm using encoder. Here what will happen, before we make these drums, we cut the steel, these are all steel drums. We cut the steel sheets into perfect length. Now we use encoder here for measurement. This is perfect. To measure the length of the encoder. As the sheet is going, a wheel will be rotated and an encoder coupled to that will measure. And I will get an accurate with 1 millimeter accuracy or something. I will be able to measure, then cut the sheets and all that. Then we dissolve hydraulic system, all these hydraulic machines. See, one of the biggest drawback is when the students come to see a plant like or whatever, even mechanical engineers or even electrical engineers, they would not have seen a valve, in a proportional control valve used in hydraulics. Because now hydraulics can be made to work like a motor by using a proportional control valve, by controlling the flow. So these are the tubes in which oil will come. Okay, so that oil will push the cylinder, this column will be pushed forward, reverse. So this is a plating. That means you see the edge. The edge will be bent by this machine. Then I will just move further. You see this type of aberrations on the drums, they are made by these hydraulic cylinders. So this cylinder will go inside, as you can see here, this will go inside, expand. So this will go inside, expand. So these grooves will expand and collapse. So when it expands, it will make an impression like this. Okay, so this is a feeling. Then you would have seen a corrugation. Okay, see now this type of aberration is done by 2 tools on the top. Again, this hydraulic, you can see this cylinder. This cylinder is pressing it now. Pressing the tool. Once it makes one rotation, this is moved by up. So like the different types of operations we do. Hydraulics. Knowledge of hydraulics is very much essential when you want to do a project like this. So at that time you can't say, sir, I'm electrical fellow, I don't know hydraulics means I will not get the order. Whereas you can afford to say, but we can't. So we should have. Otherwise somebody will get the order who has the knowledge. That's it. Very simple. For us, it's a survival. It is not that we we would like to be expert in everything. It is not possible. But we should have a basic knowledge of the system. So this is again another interesting story. This paint booth, see, there are so many types of colors that are used for this paint. This is called Fujara steel barrels. If you see here, see so many colors. This is red, green, blue, dark blue, light blue. So many types of colors are there in the barrel. Now, what will happen? What used to happen? In our original system, we had given a recipe management. We had given a simple button, Sasol, Exxon, Mobil. So you press a button, color for Sasol will be, because these are all nozzles with so many colors. Which nozzle to fire? We have to decide based on what product we are making. If you are making for Sasol, then it is all blue. All the things from top to bottom will blue. If it is something like different. Now, most of the workers who are operating on this plant are Bangladeshis, highly uneducated. Even if you write in any Urdu or whatever, they cannot understand. They don't know how to read. So what we did, we took a photo of these things. We have put it in our HMI screen. Now, by looking at the photo, he knows which to produce. Now, moment he presses that button, this is called recipe management. We write a recipe program where there will be a database. From the database, we pick up the sequence of knowledge, not only the number of solenoids, but sequence, which will come after which. All that will be stored into a recipe database. So all that I will talk a little bit. After another 5 minutes, I will go to computer science. We talk of SCADA and other things. So all those things we will talk a little bit later. So then we do screen printing, lot of types of automation we do. Anyway, I forgot to tell you one very important part of automation, which normally we use in our talks. Let me go back to this. Okay, so this is maybe some of you might have seen, some of you might have visited. I do not know, but this is for your knowledge. See, the concept of automation started from, where? It was started from automotive plants, car manufacturing. So they started the entire the concept of automation when it was very long back, like 1920, 1930, 40, in those areas. So more than 78 years or almost 100 years, the automation was there. But where is computers then? Where is SCADA? Where is sensors? Where is microcontroller? Nothing was there about in 1920 or 1940. So this was purely a mechanical automation. You would have seen, Charlie Chaplin's movie. So he will run behind a conveyor type like automation. Then came electrical automation. So electrical automation, I don't have it with me, but I could have shown you maybe some other time, because today's talk is more on, because to give you what is required for consultancy, I am trying to go through all these things. So electrical automation was started with all relays, contactors and all that, those switches, electrically operated switches. By using that, people used to automate a steel plant. In 1998, I was called from Singapore for an automation job in Vaidak steel plant. This plant was installed in 1965. Can you believe 1965, no computers, no electronics, nothing, no software. There was no word called software in 1965. So, but this is a steel plant fully automated in 1965 by using only these relays and other things. So when we automated to a most modern thing, the whole the panel, everything became so small. Anyway, that's a separate unit that used to be called as the third generation automation. Today we have all these programming devices. Once this microcontroller came into picture, then people started using a small chip. By programming this chip, that pins will become 1 and 0. It will switch on some motor, switch off some motor, something like that people used to do by using these microcontrollers. But the problem with microcontroller programming is you need a special knowledge. Kill compilers, so we use a different type of compilers. So only specialized knowledge people only can do microcontroller. Today, whatever jobs you saw, whatever automation you saw, anybody can program. Okay, so that means our controllers became so user friendly. You need not be an electronics engineer to program this. There is no need. You can be a mechanical engineer, you can be a chemical engineer. Because you should know the process. If you know the process, programming is by objects. What do you mean by object? OOPS something we call object-oriented programming structure. Coming back to computer science now. So what is object? Like your mobile, you have an app. So if you know how to use that app, what is the function of, or in calculator, simple example in calculator. When you take a multiplication, what it does, you know very well, two numbers have to be multiplied. So that means each key in that has got a function. Multiplication means it will multiply two numbers. Divide means it will do same thing in the OOPS. Like you have a PID control for drum level. So that means that function block will do everything. What is that unit? control a drum level in the water, I need a level sensor, I need a pump. That's it. That pump and level sensor, if you give it to this software, that will control the the level, the drum sequencing. So many types of function blocks are there. If you understand those objects, then you can cut and paste them and make your own software. That's the beauty of today's from the burn and all that. From that age we have come up to here. So this is what this is the growth in this field, and what is going to be future is even fantastic. But anyway, because today's focus is not automation, today's focus is consultancy in automation. So I will come back to the consultancy portion of this. Anyway, to understand this, so that means this should know what a boiler does, what a turbine does, what is back pressure. So all those things. Great advantage of automation is, without even if you hate it, you will understand the process knowledge automatically. Because without understanding process knowledge, how will you code? How will you write your program? How will you make those machines work without understanding? So that means automatically you learn the process. Okay. So without knowing the process, you cannot program. So that is the great advantage of in this automation field. You will learn many disciplines. You will learn hydraulics, you will learn pneumatics, you will learn all types of camps. Because I did a 190 mechanical students, we made a course, 1 month internship. We showed all these things to them on online. So we showed them different types of screw conveyors, different types of applications mechanically. Then we also did for electrical engineers and instrumentation engineers. This was separate. And also, you should also learn the other courses of automation. Moment you say electrical, don't switch off your mind. If you are a mechanical engineer, electrical, where you can't say. Because for us, entire project is 4.5 crores automation. That means right from 11 kV till last milliampere that we use in this sensor, whatever sensors I have on the table, they all give 4 to 20 milliampere. Why we need to use 4 to 20 milliampere? To that level, everything is to be understood. So anyway, I will also talk little bit, 2 minutes. I just have a earplug, so that I don't need to get connected wireless. So, okay, so I will just talk 2 minutes. What is the need of our in the instrumentation? Now I spoke about process. A lot of process we understood. Foundry, steel plant, that so many types of process we understood. Now let us get back to little bit about the system knowledge. So let me just, I don't think I opened this. I have not opened, I will try to open this now. So the system knowledge is so much essential, equally as important as process knowledge. Okay. So what is the system knowledge? I will try to, let me just, okay, present this screen. So I will not bore you because I exactly at 4:45, or I will close, then we can answer questions. I think you have validated the function and so many other things lined up. So I don't want to prolong any further, because when you say, otherwise generally our talk goes for 3 days, 4 days, because when we try to show so many things, it will take a lot of time, but anyway, that can be addressed some other time. Okay, for need be. Okay, let us read our okay, here. See, what is the system knowledge? Now, these are all the type of panels we produce. Different, now let us now start with electrical. Okay, first knowledge of all the motor controls, because in our system we use so many types of motors. Servo motor, stepper motor, primarily induction motor. Okay, AC motors are very popular because, if somebody asks, I keep asking this question to electrical students when they come for an interview. Which motor is very popular? Undoubtedly, most of them will say DC motor. Why? Because in curriculum you teach DC motor so much to them, not the induction motor. Then I tell them, sorry my friend, in today's world, 95% is AC motors. 95% of applications people use AC motor, not DC motor. Why? Because DC motor has commutator, brushes and all that. Every 1 month or every 15 days or every 2 months, the brushes will wear out, it will become black and open TV. So this is not maintenance. The induction motor, how many times have you opened the pump in your house for pumping the water? They are squirrel cage induction motor. They need practically zero maintenance. That's the reason DC motors are very popular. 30 years back, when we suppose if I were to do automation, like what the videos I showed you, I have to use DC motor only because changing speed of motor of AC motor was not available till 1985. Once the power electronics got developed, then we got AGVD, we got VFD, all those things, and that is how AC motors became very popular. So today, 95% of our applications use AC motors. So these are the different switch gears we use for controlling them. This is what I call system knowledge, product knowledge. What to call product knowledge, what to call system knowledge. What these are different type of starters we use for them. Then we use different type of sensors, knowledge of instrumentation. We spoke about electrical engineering. Now I didn't say much about mechanical. Some other day we have to go for a ball school. That is fine. Mechanical decision will be first. But should we go for hydraulic? Should we go for pneumatic? Should we go for motorized control? Then only all the electrical systems will come into picture. Because if you are going to hydraulics, it will be more of other type of thing. Then instrumentation. What type of sensors we should go? We should go for laser, ultrasonic. This is RTD, temperature measurement. This is for pressure measurement. Load cell for load, weight measurement. Different type of proximity switch, limit switches. So many types of sensors we use in our project. Okay, these are all hand on board and all used for automotive. That is not. Anyway, by the way, I spoke to one of the professors in the college. See, automotive is a very interesting plant, car manufacturing. The nearest car manufacturing for all of us is Toyota in Bidadi. So I did a lot of work for Toyota. When I came back from Singapore in 2005, this weld shop, a lot of part of weld shop automation was done by us. And later we discontinued for various reasons, whatever reason. Anyway, so automotive is a very interesting process. So that is where if you go, you will see a thing like this. Say in Bidadi, they make Innova car every 4 minutes. 4 minutes is the takt time. Many of you may not know that in India, we make cars at every 1 minute. Like Maruti and all, we will make at 40 seconds. So I used to work in plant in Malaysia when I was in Singapore. So we did automation of project where we used to make cars in 30 seconds, flat 30 seconds assembly. So lot of such knowledge of the process will be required here. Anyway, let us not, this is VFD, variable frequency drive for changing the speed of AC motor. Then all the other things of these are programming knowledge. So all this knowledge of distributed control, HMI, this is for human machine interface. So a lot of these knowledges are required as a process, as a system. Okay. Now, what type of networking we have to go? Should we go for Profinet? Should we go for serial port? Another aspect which is when a moment I talk about networking, our college professor says, electronics. Hey, boy, there is nothing called electronics, there is nothing called mechanical. See, I want to tell you something here. See, suppose this is ultrasonic sensor, okay, or some temperature measurement. Now, temperature will come to our controller in the form of current or voltage. Okay, that means suppose I am using for 0 to 400 degree temperature oven. Now, 0 to 400 degree means 0 degree means 0, 400 degree means 10 volts. That is how I get this signal to my controller. This is our voltage. If it is current, I get 420 milliampere. Now, I ask most of the students, do we prefer current or do you prefer voltage? Suppose imagine I have a sensor which gives both. It gives voltage also, it gives current also. Which one are you going to choose? 99% of students will say sir, voltage. All our plants are very huge. Now you saw the video, no? They are almost 3 acres, 4 acres plants. When you try to bring a wire from such a long distance, there will be a drop if you try to use the voltage. So we use current. In current also, why 4 to 20? Why not 0 to 20? I'll give you an example. Suppose I am measuring speed of a motor. So suppose I am using 0 to 20 milliampere instead of 4 to 20. 0 milliampere means motor is not running. 20 milliampere means motor is running at full speed. Okay, let us take an example like that. Then what happens? Suppose now motor is running at 10 milliampere. That means 10 milliampere means half the speed. It is running at half the speed. Suddenly, if the wire becomes open, if the wire gets cut, I get 0 milliampere. Actually, motor is running. So 0 milliampere means motor is stopped. Well, should I consider that motor is stopped? I will be wrong. If I think that motor is stopped, I will be wrong. Actually, motor is running, but my signal wire got cut. So that's why we use 4 to 20 milliampere. What will happen? Motor stopped means I get 4. Motor running at full speed means I get 20. If a wire gets cut, I get 0. So immediately if I get 0, I know that there is a problem in the wire, there is a problem in the sensor. Immediately I flash a message in SCADA saying that so-and-so wire got cut. So then somebody can go and attend quickly. Anyway, this is the knowledge of the system. One more very important knowledge required will be SCADA. which I am going to show you now, the SCADA supervisory control data acquisition. This expertise is required, very much required for students. See, this is a steel plant. You pour hot metal. You imagine a 10th floor building. Okay, from the 10th floor building, you pour a hot metal. That starts solidifying. You know what is the length from here to here? It will be almost 2 kilometers. In these 2 kilometers, every 5 minutes we catch one bar. So many measurements will be made. So many temperature, head temperature, this is head temperature, tail temperature, thickness here, edge guide, hardness. So many sensors are there. Now, can somebody stand and note down readings of all these ones? It is impossible. So that is where this software comes into picture, which will grab all this data and puts it into database, which you can analyze later, which you can analyze by using another tool. What is supervisory control? That's what I'm going to explain you now. See, what will happen? Normally, you can interface a video camera and physically see. What is below here is called alarm screens. So whenever something goes wrong, you get red color alarm. Something is healthy, you get green color alarm. Moment you get a red color alarm, normally what will happen? The operator of this plant will be sitting in 3rd floor somewhere here. He can't go to 2 kilometers, walk something and see. He cannot leave his seat. Suddenly there is going to be an alarm. I will give you an example. Below this there is going to be a hydraulic system. Because for pressing and rolling you need a hydraulic force. So this will be the hydraulic, actually this is underground actually. Now what will happen? He need not go all the way underground. He will simply press a button here, he will get the screen of hydraulics. What is the tank level? What is the temperature of the oil? What is the pressure of the oil? And how many buffer tanks are there? All accumulators. All this knowledge you will get from here only. Now imagine what will happen when he is watching this screen. Suddenly he will get one alarm, red color. Pipeline number 7 leakage. How do you know pipeline number 7 leakage? We use a very special sensor. Say this pipeline number 6 or 7 or whatever. Let us not. Suppose if there is a cut here. These are all high pressure oil. The whole bloody area, the whole room will become oil within few seconds. Because there will be such a volume of oil will be pushed out of this. How do I know there is a leakage here? Because I will be measuring pressure here, I will be measuring pressure here. If there is a difference in the pressure, I know that there is a leakage here. So immediately, system will put a alarm here, not here. So saying that there is a leakage, tank. Okay, so line number 7, line number 6, there is a pipeline open. Now immediately somebody got to take attention. What this fellow will do? He will simply go to hydraulic screen, stop that line number 7. Quickly will stop. So this is what we call supervisory control. The entire plant will be at his fingertips. He will be able to control imagine steel plant, such a huge steel plant. This one fellow will control. Okay. Now then what will happen? He will call on wireless somebody. Okay, I go maintenance people, go to this line, whatever he will call. Then somebody will go attend. Then he will put the system back into operation. All those things are done. Then what is important is he will also get, so he will also get a plot of temperature versus pressure, whatever, all continuously going on. That means every happening in the plant will be known to him. Now these red color alarms will not go away. It will not be erased. Nobody can erase this except the vice president or somebody very senior. He only can erase this. Otherwise, if operator will make a mistake and they will erase the alarm, then nobody will know. So this will be stored in another database called alarm database. So a lot of things we do, which is related to computer science, related to our mechanical engineering, related to electronics, related to electrical, everything we do. Okay, so many types of things we do. Anyway, I just gave a brief idea. Now, coming back to, I have a lot of other things to show in SCADA, but let us stop here. Now, coming back to what is important for you. What is that you can do in college? Can you become a consultant for these type of things? Probably not at initial level. If it is not possible, then what is that you can do? I will tell you some 2-3 things quickly. I will try to quickly talk about this. See, I went to Shimoga for some personal. I went to one college and gave a talk on the automation. One boy came to me. He said, "Sir, normally the bitterness trees they grow. So climbing the beetle tree is a very tricky thing, very, very specialized profession. I am a mechanical engineer, I want to do something." Then I gave him an idea of a scissor lift. No, the small scissor lift, which can take the weight of one person, maybe about 80 kgs, 100 kgs. You can design a small scissor lift which you can raise up to, because in a compact space, you can design a scissor lift to go up to that. Then that boy made a very beautiful project, a very economical scissor lift. Of course, there are a lot of deficiencies in that, but it doesn't matter. So, and again, Malnad College of Engineering, all of you know, I am one of the directors there, I am advisor there to the college. So, but how it came like that, we did a project in Hassan. Near Hassan, there is a place called, the place is some village. There is a coffee curing works. Lot of coffee curing works are there near Hassan. From the Chikmagalur coffee is some curing. We have done a lot of work for coffee curing. I don't have any videos. Anyway, they're very small, so we don't have it. Now they gave me one challenge. They said, sorry, coffee. Based on the color. Okay, that's very tricky actually. It's the color separation. You can tell us, it's not a big thing. If you go to Google and see, you will see plenty of colors and different frequency. Basically, it's a photometric. You give different frequency. From that frequency, the reflected frequency, you can find out whether red color, that color, then you can grade A, B, C. We can make a small machine to do it, but we can't do because the reason is that will require 6 months of time sitting there. If I sit 6 months, then my company will close. I have to close, shut my factory. And how many coffee curing works are there? 10, 12. How many I can sell? So we think of business. For us, if it is a 1,000 number, then I will put my head and develop. For 1, 2, 3, I can't waste time. Whereas that's a fantastic project for you. Okay, you people should take up such things. So again, the Godambi machines, lot of such ideas are there. So what I also gave one project to NIT Calicut, our professor in NIT Calicut. Because this crusher, after crushing the boulders, you make small stone, 16 mm diameter, 16 mm size, and 8 mm size like that. 16 mm, not 8 mm will come. So how do you do that? You have to take images immediately when the color belt is moving. You have to take a snap quickly or shortly. How many percentage? 8 mm. See, that will alter the job. Lot of such projects are there. Industry has got many problems. I get at least 5 to 6 like that every month, which we say, thank you sir, we can't do. Because financially not viable for us. And believe me, one more thing for us, if I become a consultant to X company, like whatever supplier I have done that blocks, if 1000 cubic meter I have to produce, I have given the commitment means 1000 cubic meter I have to produce. If I produce even 1 cubic meter less, I won't get my money. That means I cannot be 75% successful. I have to be 100% successful. Then only I get my money. Whereas this coffee grading, they want 1 ton per hour. But we cannot do 1 ton per hour. You do 1 kg per hour. That is enough. Okay, you need not be 100% successful. You can be even 50% successful. You will do a lot of work to the society. I also got a call from one college from somewhere in Bangalore yesterday they called me. Sir, now we have taken up one project for this waste disposal. This corporation fellows, they collect the wet waste. In that you will see a lot of plastics. Is there any sensor which we can use to identify this plastic and remove? So I gave them some suggestion, whatever came to my mind little. Such projects are the best projects for you people to take. The reason is they are small in size, so investments are not big, and you don't have to be 100% result oriented. And second thing is, you are doing something good to the society. Your visibility will become very big. By doing a big project in power plant, you will not be visible. There are hundreds of people like us who are doing power plant. Whereas such socio-economic projects, if you try to do, will be more visible to the community. Okay, so now chemical engineer, I have a lot of people are there, consultants from the college community. There are. Only industry people are there. A lot of people are there as a consultant in different areas. But you should know the process thoroughly. If you know the process thoroughly, if you know the system, then comes the project management, third aspect, which you anyway, many of you would have spoken about it. So this is what is required to be a consultant, and it's a great thing. Actually, in US, universities give consultancy to industry constantly. When I was working in GE in US, I was there in US. I used to go and teach in the VT, Virginia Tech. We were only 90 miles from Virginia Tech. GE gives some credit if I go and teach in the university. In my personal appraisal, I used to get one extra points. So I went and teach. I used to go and teach even in Singapore. I went and taught in many colleges. Okay. So we also did a lot of projects for colleges. One college, in Polytechnic in Singapore, I'm talking about 99. I made them do a small press, produce paper cups. At that time, paper cups were very popular. Okay, disposable paper cups. So that college made a small machine, which will produce one press will cut the paper, then fold it, one arm will come and put a glue, all those things. They printed their name, Temasek Polytechnic. So it became very popular because throughout the restaurants, everybody saw this company, this Polytechnic is producing. Look at the visibility of the college. So such projects are great projects for you people to take and be a consultant in such things. Anyway, it is easy for me to say, When I told this to many faculty, they said, "Sir, elli sir, Belagaginte Mac, MBA, they are doing all very special work. Where is the time for us to get all this knowledge? Where is the time for us to learn all these things from these and things?" They have their own problems. They keep saying, may be true, may not be true. I am not my cup of tea. But this is a great way to be a consultant, especially for colleges. If you are ahead of technology, definitely you can be more useful to industry than us. Okay, right. I hope what is required. Any questions, anything else, you please ask me. You can unmute yourself and ask. We can discuss. I hope it was interesting, was it?
Yeah,
sir. It was very interesting. You touched many areas where engineers can look for consultancy guidance. Very
There is
interesting.
need. I am sure. There is a need for consultancy in all these fields.
Yeah.
Some strong people are required.
Yes. In fact, you showed the consultancy for civil, mechanical, electrical, electronics, and computer graduates also. Very nice talk, sir. Madam, any questions from the audience? You can ask questions unmuting your mic, or you can send your question in the chat box. Sir, in order to have these process control concepts in the college, what is the investment you suggest, sir?
Actually, okay. I will share one more small thing done by students. See, investment can be right from 5,000 rupees to 5 crores. I am telling you, everything need not be brought in one phase. You can build a small phase. Shall I show you one small thing made by students?
Yes, sir.
I'll just see. I'll just see. We make a. I took one. My wife. She was a assistant professor in BMS college. Okay, now she is not there. She is with us. She in the BMS IT, BMS Institute of Technology. She was a professor there. Okay, now when she was teaching there, a lot of students used to come. Even now, a lot of students come to our college. Okay, now what they used to do, I showed one of the students this batching plant. I said, no, the concrete, we talk, this is the screw conveyor. Now I showed them what is the screw conveyor. See, one cloth got stuck here. That's why we removed the screw conveyor. All these, whatever. Okay. Now one student did a small model of this batching plant. This whatever batching plant I showed you, this concrete batching. There are bins. This bin, the pneumatic gate will open. This is the belt conveyor feeding it, and all that. Just now, what a skip bucket is going up, feeding this metal into mixer. So they understood the concept and they did it so well. In fact, we funded that project. Okay, so we funded that project and we have kept it in our. One minute, let me just see here. We in fact, it was so nice that we decided to keep that and fund the entire system ourselves. Okay, so if such people are there, we are ready to put the money. Okay, here it is. See, this is that batching plant. It's a working model. We still have this with us in our plant. So these are the different bins. This is a motor gate opening. This is a traveling bucket. It's a load cell. So this will go collect all the material, then dump it into the bucket, and this will go up. Fully working model. They made. All the students do this. So now to make something like this, you don't have to invest a lot of money. Okay. What you have to do? Some basic infrastructure you have to invest, like this. Whatever I have here. Okay. So. This is actually one PLC with HMI, one servo drive, ball screw, okay, one induction motor. So this is actually my training kit. Actually, I use this to train our own engineers. Because our own engineers, whoever joins, they need a training. So we develop these type of things. Then we had also made one very interesting kit for electrical department. Okay, so here this is the induction motor trainer. What happened? This is actually we don't manufacture these things. Okay, what we manufacture is very huge. We make this type of very big panels. I showed you just now. So we make that type of very huge panel. So we have no intention to make these type of things. Okay, this is a kit where you understand complete about induction motor. This is called induction motor training kit. We made it for ourselves. Okay, with one PLC, small HMI. This is a DOL starter, star delta starter, then the VFD for control of speed. Then BNM8, there is one college. They saw this other number about 30 faculties came for one FDP, for faculty program in our faculty. They came, they saw this, they said, sir, we want to buy this. So then we made one and we gave to them. And there are a lot of colleges are buying this type of kits. MC Hassan, they are also trying to do a lot of work, whatever the zero speed switch I explained. Some miniature models of this. You don't have to buy entire stuff together. You can build your lab. What you should do, you should have a one focus. You should have one idea. Yes, I am going to build a lab of this nature, which will cost so money. But you don't have to do everything together in one shot. You can slowly build. Because say there are some companies they make. There are some people who make education trainer kit and all that. I am dead against such things. Because whatever I have seen even in NIT Calicut, I have seen they supply something, they run away. Okay, because they're all education. In college you can afford to supply something and run away, but I cannot do that in industry. If I supply some nonsense and run away, within no time my name will get spoiled. Then I will never get order. Okay, I have seen when I went to NIT Calicut, somebody has supplied a stepper motor and belt conveyor. One research scholar wanted to do some automation on that project. He came to our seminar. He said, "Sir, can you spare one more day? Have some problem. These equipments are not working." Luckily, they all had Siemens PLC, not Siemens, GE PLC, where I was ex-GE email. So I had a software, I plugged it, immediately made some 10 minutes coding and made it work. So this is a drawback because people who are from industry don't come here because it's not a big business. How much will that kit will be? It will be 50,000, 1 lakh, 2 lakh. It's too small for us. So our orders are in the terms of 4 crores, 5 crores. Okay, so but those who are in the industry doesn't come. But what I am doing, I will give you suggestion. Okay, you can build your own kit. There is no problem. I will give you drawing. I will give you all details. So have one picture how your lab should look like. Because if you don't think like this now, another 5 years will become redundant. I am telling you. I am not scary, but the technology keeps going very fast. We cannot still keep on talking about one particular law. We have to go forward. We have to move forward and try to teach because next 10 years things are going to be so deep. For fifth semester electrical students, we taught. I myself went and made a talk, complete, including practicals, theory, everything, including setting question paper, even correction. I went to, this is a new experience for me, when I went for paper correction, all the people are looking at us like this. Hey, this fellow doesn't look like a fact. To go for correction. And my wife went and did the correction for the evaluation. All that is a nice experience, but a lot of time is invested for that. So what I'm telling, when you make a syllabus, a lot of opposition came. Now where is the textbook for this? A lot of these subjects don't have textbook. Okay, there is no textbook for such thing, and that teaching from textbook should be stopped because otherwise your knowledge will.
ಇಲ್ಲ ಸರ್ ಈಗ ಕನ್ಕ್ಲೂಷನ್ ಇದೆ ಕಿತ್ಕೊಂಡು ಹೊರಟಾಯ್ತು
on limitations. The colleges will have their own limitations.
Anybody? Anybody? Any participant has a question to ask?
Hello. This talk was useful or interesting to you?
Hello. Hello. Any participant has a question to ask?
Hello. This talk was useful or interesting to you?
Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello. Hello. Any participant has a question to ask? Hello.
Sharaf, you want to ask something? You had unmuted earlier. Sharaf?
No.
No.
Madam,
Okay, sir. Thank you very much. No more questions, sir.
Okay, thank you.
Nicely explained as various areas where different engineers can look for consultancy, like in data collection,
then
wall construction, process automation, then conveyor build control process, and the system knowledge the students should have, circuit breakers for security, then barrel preparation automation, painting automation, motor control and supervisory control, various controlling areas you introduced us, sir. It was very nice, an elaborative list of opportunities for engineers in the various branches. Thankful, sir. Thank you very much from our side. I'll now hand over to Smita Madam for giving vote of thanks to the speaker. Madam.
Thank you, sir. Thank you. I would like to thank Mr. R. Venugopal from Venugopal Automation. He has been talking about a lot about big projects, and though it looked threatening in the starting, we have realized that even those big projects can be miniatured for many smaller companies. So he has even motivated us to make those big projects into a smaller one, miniature ones, where the application will be for a smaller size. And also it has been recognized now because of him that we can try to do something that we want around us. Whatever is wanted around us, we can think over and we can try to build up whatever we want in our college, etc., for our homes and so on. Thank you very much, sir. It has been very informative and very entertaining because we have even seen a lot of videos that were which would not generally would not have seen. Thank you very much, sir.
Okay, thank you, madam. Thank you. I think it's almost 1.5 hours I spoke continuously.
Yes, very nice.
Very nice.
Okay. So if there is anything, you please walk down. We are now we have an office in the Jayanagar, West Block. So all our days we sit here. If you want anything, you are most welcome. Okay.
Yeah,
We'll be in touch with you, sir, for your help and other things.
Okay.
Thank you.
Right. Thank you, madam. I'll take leave now.
Okay, thank you.
Now
We'll have a valedictory. I requested principal to join. He has not joined it. So as a part of this valedictory, I welcome the participants for today's valedictory function of 5 days live seminar titled Friends and Opportunities in Consultancy and Management. As a part of valedictory function, I request the participants to give your feedback. Anybody? MNS, sir? Hello? MNS available? Kalpana madam, please give your comments about the program. Hello? Anybody? Anjula madam. Hello.
Hello.
Madam. What is your
experience?
Sir, the program was went on very well, and it was very informative, and it was very helpful for all the beginners, sir. And especially today's talk was very nice.
Yeah,
This was mainly arranged for beginners only, madam. In the coming weeks, we will arrange advanced areas where consultancies are going on. This is for the faculty to get ready for consultancy. What are the basic requirements?
Yes, sir.
Shantala, madam. Shantala NL.
Yes, sir. Good afternoon, sir. From the day one till the last day session,
Yes, sir. Thank you,
really
sir.
it was very informative, sir. Because a few sessions I missed because of online classes, but a lot of information we have gathered such that it was very motivative for ourselves to enhance the knowledge and to provide information to the students and to make any of the small level in the even the project, the integrated approach is required to come out as one system to work. Really, it was very informative and wonderful sessions, sir.
Thank you.
And
Even
even the recordings,
we have
Yes, sir.
put in
the YouTube, I will share the link.
Yes, sir. Yes, sir.
Share the link. You can listen leisurely.
Yes, sir.
And,
Practical, especially as Madam said, this session was very nice so that all the integrated approach which is required, practically it is shown, and knowledge aspect, how much we have to enhance ourselves to give the information to even the student level. Really, it was very good, sir. Very nice.
Yeah, the intention was that, madam, let us put the foundation first.
Yes, sir. Yes, sir.
Inform all the faculty need
Yes, sir. Yes, sir.
and
Required skills.
Yes, sir, of course, 100%. We have to change our thinking levels, really.
Yeah.
It is there, but with thorough information, we have to step into that such that, as earlier sir said, by doing mistake, we learn a lot. So we have to get into that newer field, enhance ourselves, and it helps for ourselves personally, professionally, and institute level, then to the students. That's what I have understood.
Yes.
Thank you very much.
Thank you. Thank you for your
Thank you. Thank you.
Thank you.
Thank you.
Yes, yes.
So, Vidya madam.
Good evening, sir. Am I audible?
Yeah.
Go ahead, madam.
Okay. It was indeed a nice presentation on consultancy and academic interaction, sir. So we got to know a lot of things from this. As you know very well now, because of NEP 2020, a lot of revolution have taken in the field of education. We have to see from the view of consultancy and what's going on in reality now with the current trend. We have to focus much on this to the students, as students are very much interested in the field of engineers. So in this view or in this regard, we have to work and we have to give them the knowledge. So for that, this industry and institute interaction is a must, is what I felt.
Yeah.
Because in future, we have to get into the field rather than sitting in the classroom.
Yes, sir. Yes, sir. So a lot of internet stuff is available wherein which they can gain knowledge regarding the basics is what I felt. But what is in reality or real time advanced technology which is going on is what we have to concentrate and upgrade our knowledge so that we are into that competitive world.
Yes. Thank you.
Thank you, sir.
Sir, Niranjan sir. Are you there, sir?
Niranjan.
Pushpanjali,
madam.
Sudha. Sudha
Bhuvanagiri.
Yes,
Yes,
sir.
sir. Go ahead, sir.
Hello, sir. The workshop went on very well, sir, and all prominent speakers from various fields, sir.
Yeah.
And so I got a lot of information about consultancy, and I am also very keen on. I was also working in industry for 2 years, and it is very interesting, and so there is a lot of scope for consultancy. If one academician made up their mind to start in that direction, and so a lot of information I gathered. The workshop was very well conducted. Thank you very much.
Thank you. In fact,
Good evening, sir. Good evening, sir.
Tell me.
Sir, it was a wonderful session, well organized and very informative, sir. And especially the last session, the real-time application, it was very good, sir.
Yeah.
Because
Thank you, sir.
we hear a lot of theory,
Yeah.
but that man, without showing even single slide, he explained all concepts.
Yes, sir.
Yeah, you rightly said, madam. It's correct. In fact, we also have to teach in future like this only.
Yes, sir. So even the students, they'll feel interesting rather than the theoretical aspect. We have to go for the real-time application, sir.
Not only that, madam, now the information is available everywhere.
Yeah.
So
if we give the same information in the class, they may not come because they, in the fingertips they have information.
Yes, sir.
So
So we have to give them knowledge rather than information.
Yes,
So
sir.
then they will come to the class.
Thank you,
Thank you,
madam.
madam. Thank you very much.
Okay. Thank you, sir.
Vijayalakshmi D. Would you like to speak, madam? Vijayalakshmi. Veena, madam, is there? Veena HS. Suresh. Suma, Sujata. Anybody?
Hello, good evening, sir.
Yes, madam. Go ahead, madam. Vijayalakshmi, madam.
Sorry, sir, I was traveling, I was not able to
Okay.
join. Thank you very much, sir, for the 5 days SPP. Actually speaking, we were not consultancy, incubation center, student center, teacher center and all. At least through this FTP, we got to know some new words there. And I liked actually Umar Reddy madam presentation. It was nice. Without any PPT, madam also told about all the effects of consultancy and all. It was good, sir. Thanks and good appreciations from my side. Thank you very much.
Thank you. Thank you.
Umar
madam also told that
a lot of opportunities are available for women. Umar entrepreneurship.
Yeah, what is the role of consultancy in institution? That was nice. Yeah, it was a new aspect actually.
Yes.
Thank you for your part for conducting such a wonderful session in DIT. Thank you.
Thank you.
Anybody else?
Dhanalakshmi, madam.
Sudha,
Madam. Let me give any comments.
Jyoti,
Madam.
Good evening, sir. This is Siddha from Electrical Department.
Okay.
This webinar was really very much necessary in the present situation, wherein everyone were wondering about what is consultancy, whether I can do it or anyone can do it. in that scenario, this webinar gave information, lot of information to all our teaching faculty about anyone and everyone can start off consultancy provided they have the expertise in the domain knowledge. And we were also given information about how to start up, how to move towards the consultancy. And thank you very much, sir, for this webinar.
Thank you, madam.
What I feel is because our faculty can teach what is there in the books after reading, understanding, they can easily do consultancy once they come to know. I feel consultancy is easier than teaching in a class. What's the only thing is they need to enter into the field. As you said, this series should give them an encouragement to jump into the consultancy. In the coming years, we would like to see our teachers providing consultancy to the industries.
Thank you. That goal is served, sir. I congratulate all the CDC members who did great effort in conducting this program. Thank you, sir.
Thank you. Thank you. Anybody else want to talk? Okay.
Good evening, sir.
Madam.
Please. It was one session which I like is the session from Subramanian sir. Like give us a lot of information like how to approach the companies, like what is required, what is the basic thing that is required in order to approach the companies. So you get a lot of information. So that session, it has motivated all of us to approach consulting companies. Thank you for the session, sir. Thank you for conducting this wonderful activities. Thank you also to all the organizers. Thank you, sir.
Thank you, madam. Thank you. Anybody else?
It is a very wonderful session, sir. We are getting more knowledge from different eminent persons. We have get some idea how to do consultancy, and rather than the theory concept, we have to do some practical oriented. Generally, we gain more knowledge. We are exploring so many things. So, thank you for conducting this session, sir. Thank you for all team members and faculties and organization. Thank you once again, sir.
Thank you.
Sir, now we have our principal. Sir, welcome, sir.
Thank you, Professor.
We are just taking the feedback from the faculty.
Okay.
Sir,
can you say a few words, sir, to the faculty?
Now, I'm just hoping that all of them will start in a small way, take some steps to start in the direction of consultancy and research. And it is not an easy job, as RV College principal was telling. They have taken almost more than 5-10 years to develop good consultancy and research centers at their college. And definitely it will take a minimum 4 to 5 years to move forward. And as Tempana was mentioning, maybe we can organize one more session where we can discuss on some of the small projects, how exactly we need to handle the projects. Maybe we can involve some of the people who are already doing consultancy to explain what they are doing and what steps they are taking. That may give a direct motivation for the members to take on. And I think all the participants are well educated. They know what is required. Only thing is they should decide. So making a decision to take up consultancy is most important. So if they decide, then automatically everybody is capable of doing consultancy and research. I hope for the best in the days to come.
Thank you, sir. In fact, our
faculty, some of them are now motivated. They are feeling that it's possible to do consultancy. That is a great booster actually.
Yes.
Some of them in their feedback they have expressed that now they know what to do. So as you said, in the coming years, we'll expose our faculty to the more details on consultancy, so that they'll get prepared for providing consultancy in future. Sir.
Yeah, the simple way to start off is those who are fresh. Now we have signed some MOUs with the organizations, whether they're small companies or big companies. I think get in touch with them, have discussions with all those companies that we have signed, and see what is possible to do with them. That is the first stage. So that will be the impetus and the first stage of interacting with the outside world. And then gradually we can have, there are a lot of companies who are visiting for campus recruitments to the IT. They have also expressed again and again that they can give some projects to the faculty members interested to work on. And each department has got a faculty coordinator for placement. So when companies visit for campus recruitment, please interact with them and explore what possibilities are there to work together. So that is the second step. So first one is interacting with all the companies that we have already signed MOUs. And next, exploring the companies in our competency levels, capability levels, and getting them on board with DIT, signing an MOU, and then interacting with them to do project works. I think the telecom department has already started in this direction. They are working closely with some of the projects. Dr. Rajeshwari and Dr. Chandala, they have been, Chetan Anand, they have been working with some of the companies. So similarly, the other departments also can start exploring the possibilities with the already signed MOU companies. So that will give the direction to move forward.
Yes,
rightly said. Even electrical department can start. Just now, Venugopal automation.
Yeah.
They gave a detailed list of the opportunities for different branch of engineers. They are also a good source in teachers. They have a lot of projects and they are interested in training final semester students also. So we can have an MOU with them. Even mechanical engineers also can have an MOU with them. Electronics, electrical, mechanical. That we have to discuss that. We have to discuss with the individual department and identify the areas, and then go for the companies to have MOU with the students going to their industry every year. Since just signing MOU, as you said, we'll have to look into the involving the faculty and the students in the work in the industry.
Yeah, you're right. I think the frequent meetings by the Industry Consultancy Center will definitely take us in the right direction.
Yes,
sir, we will do that. We will do that, sir, definitely.
Yeah.
Thank you,
sir. Thank you.
Anybody else want to say anything? Lalita madam? Lalita madam, want to say anything? Hello?
ಅವ್ರು ಗಾಬರಿ ಆಗೋಯ್ತು. ಕಾಫಿ ಟೀ ಕುಡಿತಾ ಇದ್ರು, ನೀವು ಕ್ವಶನ್ ಕೇಳ್ಬಿಟ್ರೆ.
ಮೇಡಮ್ ಏನಾದ್ರು ಹೇಳ್ತೀರಾ?
Hello, sir.
ಸರ್ ಆಕ್ಚುಲ್ ಆಗಿ ನನ್ನ ಸಿಸ್ಟಮ್ ಮೈಕ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ, ಅದಕ್ಕೆ ನನ್ನ ಕೊಲಿಗೆ ಇಟ್ಕೊಂಡು ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್. Sir, actually, I like this session what we did it today, because what sir told it, I think it's the same thing what we experienced it, sir. Because we have invested our 4 years in engineering, and after 4 years of engineering, when we land at the job in industry, we have to learn everything from the scratch. I think that is what I felt today it is lacking education industry, sir. So as sir told, we're learning so many subjects starting from control theory, microcontrollers, programming, everything, but we lack in understanding where it is practically used. So as we faculty, we start teaching the students from perspective of practical application. I think students will also be more interested in learning those concepts rather than just only theory. So what I would suggest from my perspective is that we should emphasize more on the practical issues rather than completely pushing them towards CGPA or their scoring. That is my
Okay, madam. Thank you.
okay.
Sir Chetananand.
Nobody else is there.
Now I
request Kempanna to give word of thanks.
Thanks, sir. Good evening, one and all present here. Respected Principal Dr. M.U. Aswath sir, our beloved HODs of all departments and professors, and my colleagues and participants. And I deem it is a great honor to propose the vote of thanks to all who have helped us in making this webinar such as resounding success. First of all, I would like to propose heartily vote of thanks to Administrator and CEO of Rajya Vakkaligara Sangha and our Principal Dr. M.A. Aswath sir, and our eminent speakers and distinguished personalities like Dr. K.N. Subramania, Principal, and Dr. G. Sobha Madam, Professor, and Umar Reddy, MD of High-Tech Magnetics and Electronics Private Limited, Mr. Prabhudeva V., Consultant TCS Bangalore, Dr. Debabrata Samantha, Consultant and Professor, Department of Computer Science, Christ deemed to be University, Sri Chandramohan Umapati, Co-Founder and Consultant, Banasri Renewable Energy Systems Private Limited, Sri V. Prasant Rao, Subject Matter Expert and Consultant, and Mr. Venugopal, Managing Director, Vijay Automation Private Limited, for gracing 5-day webinars. Thank you, sir, for your very interesting and thought-provoking talks. I would like to thank our distinguished speakers for making excellent presentation and making this webinar interesting and meaningful. I would like to express our profound gratitude to our principal for the presence in the webinar, and also I would like to thank our beloved Professor Dr. Nagaraja sir for his moral support and guidance. I am happy to express vote of thanks to our staff members who have made this webinar a grand success. I thank all those who have participated overwhelmingly and making the event success. I would like to thank the consultant development team members for making this webinar great success. Thank you so much for cooperation. Once again, I thank all of your cordial and cooperation. Thank you, sir. Thank you, one and all. Thank you again, sir.
Thank you, sir, for your vote of thanks.
My special thanks goes to Dr. M.U. Aswath for his constant encouragement and particularly his participation. Even though whenever I called him on a short notice, he agreed and promptly joined the session and made it successful. Thank you very much, sir, for your encouragement. I hope we do something during your leadership this year so that it becomes a memorable one in future. That assurance I would like to give in this session.
Thank you, Professor.
Thank you, sir. I thank all the HODs of BIT as well as faculty of BIT for cooperating with us, and our CDC team members who worked on in identifying the speakers as well as doing the necessary work to make this event successful, and particularly all participants who joined and made this session successful. Thank you all, and thank you once again. With this I close the session, and I will send the feedback for today's session as well as overall session. After you enter the feedback for the overall session, we will send certificates to you. Thank you one and all. Have a good day. So I will send a feedback for today's session. Sir? It is sir. ಹೌದಾ ಓಕೆ ಅದು ಏನಂದ್ರೆ ಈಗ ನಾವು ಬೇರೆಯವ್ರಿಗೆ ಹೇಳಿದ್ರೆ ಅಂದ್ರೆ ಅವ್ರಿಗೆ ಟ್ರೈನಿಂಗ್ ಕೊಡ್ತಾ ಇರ್ಬೇಕು, ಅದೊಂದು ದೊಡ್ಡ ತಲೆನೋವು ಸರ್. ಹೌದೌದೌದು ಹಾಗಾಗುತ್ತೆ. ಆಮೇಲೆ ಒಂದು ನಿಮಿಷ ಸರ್, ಒಂದು ನಿಮಿಷ ಆಗಿದೆ ಸರ್.